Bismillahirrahmanirrahim. Greetings. The video lectures in my channel consist mostly of some selected topics in mathematics from the curriculum of freshman college mathematics courses. Now, your feedback and your suggestions are welcome. Please indicate them in the comment section below. And also, if you have any topic that you want me to give a lecture at the freshman and sophomore level college, please indicate them, and if I notice it, I will prepare that topic, that lecture for you. Now, let's get started for today's lecture, shall we? Now, I have been asked to discuss, to give a lecture about different methods used to solve a quadratic equation. Now, first we have to know what a quadratic equation is all about. And so let me say what orally, then I zoom it up, and I have written them and put them on the board for you. Quadratic equation is a polynomial equation of degree 2. So right now we have to know what polynomial equation is, which means we have to know what polynomial is. And then also we have to know what it means by degree. What is degree of a polynomial? Now I have put them in writing again, I'm repeating myself, I put them there, I'll go over them. And the point is that mathematics is such a meticulous and precise subject. Every single word used, you have to know the meaning, definition of that in order to fully comprehend the concept. If any of them you are not familiar with, it's like a broken chain. You may not comprehend the rest of the topic under consideration. So I'm also very meticulous in that subject. Okay, then let me now go ahead and see what is polynomial. Let me zoom this one if I may. Okay, let me stay out of your way and see what polynomial is in general. Polynomial is an algebraic expression in this form. Stop and say what is algebraic expression. We concentrated on algebraic expression before we continue. Now, algebraic expression is a expression, mathematical expression, that is used variables and numbers glued together using addition, subtraction, multiplication, division, and also extraction of root, that we can say they are, like, let me make an example, like you have, let's say 5x squared plus 7x plus 9, you are dealing with numbers and variables, and the operation you are using in this example is addition and multiplication, so that makes it an algebraic expression. Then what is not algebraic expression is like a trig equation, like sine squared plus cosine squared minus 5x equal to 0. That expression is not algebraic. Also, when you will be taking calculus later, when you are dealing with differential equation or equation dealing with dealing with derivatives, so they are not algebraic expression. There are quite many other ones, but this few is enough so that you fully comprehend what algebraic expression is. Now, every polynomial is an algebraic expression, because look at that, consists of variables and numbers that they are glued together using addition and multiplication. Now, in this case, the an, then an minus 1, and so on, they are numerical coefficients. And the an means the number that correspond to x to the n. So that is why we use an, but in reality is a number. And degree of a polynomial is the highest power that x has. And the power that x can assume must be a non-negative integer, which means there should, the n can be 0, 1, 2, 3, 4, 5, and so on. N cannot be 1/2 or 1/3 or 2/3 or pi or something like that. No other except what? Except integers, positive and 0 integer. And also, since addition is commutative, therefore if they are not in descending order that I have written, it doesn't matter, you can put it in descending order. But if it is not, you look for the highest power of the x, that will be the degree of that polynomial. And the leading, this is called leading coefficient, this cannot be 0. It's a number but cannot be 0. Simply if it is 0, then the degree of the polynomial will be the next one, which is less than n, whatever it is, and is the bigger than the rest of them. That will be the degree. Okay, now we are familiar with polynomial. Okay, now let's see what is the general form of a polynomial equation, and what is the difference between polynomial equation and polynomial function. This is also important to see. Now, let me put this one up. Now, ax squared plus bx plus c equal to 0 is a general form of a polynomial equation, and here a, b, c are numbers. I come back what kind of numbers they can be. That's what the method, a different method comes into the picture. And the leading coefficient of x squared is a. This cannot be 0. Because if it is 0, then this term is odd, then we are not dealing with quadratic, we are dealing with linear. Do you see that? So a cannot be 0 because we are talking about what? About quadratic. Now, corresponding to this quadratic equation is this quadratic function. As you can see, they are same as far as the ax squared plus bx plus c is concerned. But the difference is that here, x can assume infinitely different values. We can assign for x infinitely different values. As a matter of fact, those values can even be selected randomly. You follow me in this case? But this is not the case for this one. This one will have either no solution, depending on the set, or two distinct solutions, or one solution, which in reality is 2, but they both are same. That will be it. So there is a finite solution for that. And those solutions, those numbers that satisfy x, makes the equality a true statement, they cannot be selected randomly. You follow me? This we can, here we cannot. And also, when we solve this one, this, another name for them is called the zeros or roots of this polynomial function. So whatever the x can assume to make it 0, that whatever the value x can be assigned or can assume to make this statement true, that are called zeros of this polynomial function, or what? Or they call it zeros or the roots of that polynomial function, quadratic function, excuse me. Okay, now let's go to the 5 techniques that is the topic of this lecture. What are the 5 methods that we can use to solve a quadratic equation, depending, again, I repeat myself, on the set that I'm going to talk about. Now here, I could come up with 5 methods. If you have any other method, please indicate that in the comment section for me. Now the 5 methods are used to discuss the solution of a quadratic equation. The performance of one method over the other one, because we asked why should we use this method over the other one, depends on the given set. So I come back to that to make it clear what I mean by that. Okay, then we have 5 methods to go with. So let me now give those 5 methods for you. And let me also go and zoom this one in case, because this is different. Okay. Oh, excuse me, I should have not done it. My apologies. Now let me go back. Yeah. Okay, no harm has done. Now, the 5 techniques are this. One is taking a square root of both sides. We are going to come back to that. Second one is factoring. Third one is completing a square. Fourth one is quadratic formula. And fifth one is graphing. Now, completing a square in reality is the mother of all of them, which means can be used to solve all other techniques. Applies to all other techniques. And quadratic formula is derived from completing a square. I've already uploaded a full lecture about that. And I may also upload one more just to go with this. And completing a square plays very, very important role because quadratic formula is a filtered version of completing a square. So quadratic formula is derived from completing a square. So you are not going to follow recipe and parrot-like to plug ABC and find out what is the answer without knowing where they come from. That is not mathematics. The critical thinking is where does quadratic formula come from, and that leads you to go through the completing a square. And finally, the last one is graphing. By graphing technique, we can also discuss about solution of a quadratic equation. Now, let me go to the solution by first one, which is taking a square root of. And I want also to cover this if I may. So let me now zoom it if I may, huh? Yeah. Okay, is it clear? Now we want to solve this one. In this case, the example that I made is that b is 0. You see that? When I have x squared minus 4 equal to 0, they are given to us to solve, is same as this one. A, in this case, is 1, the leading coefficient. B is 0, and C is what? Is negative 4. So if we want to put it in that form, we write 1x squared plus 0x minus 4 equal to 0. That will be this one. So this is the general form of a quadratic equation. Now, what we do, we take a square root of both sides. And we are familiar how to do that. Now, by principle, a square root of a square is not plus or minus 2. Remember that one. Is not plus or minus 2 by principle square root. A square root of a square is a square root of 4. then a square root of x squared is absolute value of x. It's very important to know. I have already uploaded a full lecture about that, and again I may be talking about that in the coming lecture because so important it is. So when absolute value of x is 2, then the values that x could be or can assume is 2 or minus 2. Because absolute value of 2 is 2 and absolute value of negative 2 is also 2. So the values that x can assume is plus or minus 2. Do you follow me? So that's very important to write a square root of x squared is absolute value of x. Not equals to what is not equal to x. So that is the solution. Now I go to the contrast to see what I mean by contrast. Suppose that we are given x squared minus 2, rather than x squared minus 4 equal to 0. They want us to solve this one. Now, this, if they ask us in the set of integer or in the set of rational number, this has no solution. Do you follow me? Why? Because there is no number that if we square it, we get 2, so that we can add to negative 2, we get 0. There is no number. No what number? No integer number. No rational number. Can you think any number that if you square it, you get positive 2 out of it? There is none. So in the set of rational numbers, we just conclude quickly that this has no solution. Now let's go and expand our set to the set of reals, and we will see that this will have solution. So let me go now to that one. Again, let me cover that one and see what that means. Now here, x squared minus 2 equals 0 has two distinct solutions in the set of real. I repeat myself, in the set of rational, this has no solution. Let's see how we find those values. Exactly like previous one. We take a square root of both sides, knowing that a square root of x squared is equal to absolute value of x. It's very, very important. It's not equal to x. And also don't write a square root of x squared equal to a square root of 2. That is not also true by principle of square root. So a square root of x squared is absolute value of x. So absolute value of x equals to 2. Therefore, x can be either negative square root of 2 or positive square root of 2, and neither of the two are rational numbers. So this does have solution in the set of real numbers. So this is the two solutions. Now, in contrast, let's see what we can do if that was not negative 2, if that was plus 2, like we have here, x squared plus 2 equal to 0. How do we solve that one? Now, can you, in order this equality to be true, to hold, x squared must be negative 2. Is that right? But there is no such a number. There is no real number that if we square it, we get negative 2. No matter what the number is, if it is negative or if it is positive, if we square it, we get a positive number. And positive plus positive is never equal to 0. The least x can assume is 0. And 0 squared is 0, but 0 plus 7 is, 0 plus 2 is not 0. Therefore, in the set of real numbers, this does not have any solution either. So then the curious question to ask, is this one has a solution at all? Is there any set bigger than set of reals that contains the solution of that? This is a very good curious question to ask, and the answer is not only yes, but also we have a theorem about that. And the theorem is called fundamental theorem of algebra that guarantees that every polynomial equation in this case, or any, let's say, polynomial this is a quadratic equation. Any polynomial of any degree n will have exactly n zeros. That means in the set of complex number, we will have exactly 2 zeros in that set. But they are not real, they are complex. That is also a lecture of its own. It's not difficult. And again, I repeat myself, the fundamental theorem of arithmetic guarantees is a theorem, which means deductively has been proven. You cannot produce any counterexample for that. Okay, now let's go to the next technique, which is the technique of factoring. So that is the third one that we are discussing, the factoring technique. Now, let me cover it again. Suppose that we are given this one, this problem, negative x squared minus 7x plus 12 equal to 0, and they emphasize to solve it by factoring. So that is the technique we are asked to do. We can do it quadratic formula, we can use the completing a square that is coming later, but we are requested, especially for the beginner, that they are first exposed. They are not yet exposed to completing a square and quadratic equation yet. So how do we do that? So the student come to me and he or she say, I have a faintest idea how to start with, and I don't know what factoring means. So first let's tell him or her what factoring is. Now 2 plus 4 equal to 6. Is that right? 2 times 3 is also equal to 6. Now 2 and 4 are called terms, and 2 and 3, when we multiply them, are called prime factors of 6. Prime factors of 6. So when we multiply them, we get 6. That's exactly what we are after. This is given us in the form of 2 plus 4, and they want to ask us what is the two numbers that we multiply, we get this one. Okay, still I don't know how to start with the student. So one of the strategy of problem solving that I have uploaded a lecture about that in my channel is, if you are encountered with a problem that you have no idea how to start with, make an example of your own that you are familiar with, and that will give you the hint, and follow that one as an algorithm, in a sense, as a prototype to solve the one that was difficult to begin with. So here what I do is this one. I make an example that I'm familiar with, because factoring means product, so I put the product of two factors here. You see that? X minus 2, x minus 3, then I go ahead and distribute, and I get this out of it. Do you follow me? So this is terms, like 2 plus 4. This is factor, like 2 times 3. Do you follow me so far? Okay, now, excuse me. Now, here, notice that when we multiply, look at that. 2 times 3 is 6. You see that? The constant term is the product of these two, and this, the coefficient of x, is the addition of these two. Do you see that? So that gives us the hint that we go ahead and try to open 2 parentheses for this, and we write x minus in one parenthesis, close the other one, x minus again, second parenthesis. Now we have to look for 2 numbers that when we multiply them, we get 12. When we add them, we get negative 7. So you go and use a trial and error technique, try a few of the numbers. If all those integers you try and didn't work, then you said this is not factorable. You cannot factor it over the integers. Can be factored over real is another story. Do you follow me? So I leave this one for you to finish. So open 2 parentheses, look for 2 numbers, But when you multiply, you get 12. When you add them, you get 7 with negative, and see what those two numbers are, and then set it equal to 0 and find the value of x. Okay, then let me zoom this one back, say a few more words, and close today's lecture. Okay, then, as always, I thank you for watching, and I hope these videos are beneficially. And as I mentioned in the beginning of the lecture, if you have any special topic at freshman, sophomore curriculum college level, please indicate them in the comment section below. And as I mentioned, if I notice it, I will try to give a lecture for that. Okay, then for the second time, I thank you for watching. I hope these videos are beneficial to you. They are for general public. And I wish you all prosperity and good health. And please stay and remain safe. So long.